So today we will start with some introductions. Okay, I will share some whiteboard, and then after introduction we will get into the software.
Okay.
So let me know where can you able to see my screen?
Yes, on whiteboard is visible.
Okay. Okay. First we will start with what you mean by STAAD. Do you have any idea?
Okay. No, I don't have.
Okay. Structural analysis and then design software. Okay.
Okay.
We can say STAAD Pro now, so that's why we can call structural analysis and design program.
Okay.
Okay. And what do you mean by structure? Like structure is something we can say like a combination of lots of structural elements. Okay, we can call it as like combination of structural elements. Then structural elements in the sense, what are the things it will come?
There will come one pillar, rafters.
Okay, so like that it will go, right? Like you will start with the foundation of footings, you can say. Foundation we will call foundation, and then we will go for a column, and then beam, and then slabs. Okay, these are the structural elements for any building.
Okay.
Okay. How the load pattern it will be?
The load pattern.
So we will be having lots of loads now. So all this load it will go to slab first.
Okay, like this, yes.
Yeah, and then it will go to beams.
Then column.
It will go to column. And it will go to footings.
Yes.
And then directly to the ground. Okay, this is like a load pattern. It will be like acting on the buildings. Okay.
Yes.
From slab it will go to beams, and then beams to column, column to footings, and then directly to the ground. Okay.
Yes. Yes.
Okay. And what are all the we can say like the types of loads? What are all the types of loads we do have?
We have seismic loads.
You are telling like this now. Okay, seismic loads. Okay, seismic gravity loads. We can say like that.
Yes.
And then we can say lateral loads.
Lateral loads.
Okay, and then we can say wind loads.
Wind loads.
Okay, and what else?
Snow load. Snow load.
Okay, but snow loads and everything like here we don't consider because it is very negligible because we are living in a Gulf country, so snow load it's not a matter, but it is also a type of load as you say. Okay, what else? Like it's all some kinds of loads and based on the how it is going to behave, because seismic in the sense it is related to the earthquake.
Yes.
Okay, gravity load in the sense we can say like dead loads and something self weight of the structural elements.
Yes.
Okay, and then lateral loads we can say like what are the loads which is going to act on the beams and columns. Okay, we can call like some uniform distributed load, uniform varying load, or point loads, or concentrated loads. Lots of things we have. Wind load in the sense because of the wind. Snow load in the sense because of the snow. Okay, okay. But we also need to know like these things. This is common, right? Like we have like a concentrated load, concentrated or point loads.
These are also types of load, but on the basis of
application.
Application.
Yeah.
Yes. And seismic, gravity, lateral, these are types on the basis of?
On the basis of like we can say seismic gravity and everything. No? So on the basis of external factors.
Okay.
This is like based on the application. These are all the basis of factors. Okay, then we can go for types of structure, types of supports. So loads, how will it will happen? Like it will act on the supports, right? Like then we need to discuss about types of supports. And what are the types of supports like we do have? So simply supports.
Simply support. Fixed support.
Fixed support. And then cantilever support. Overhang supports. Okay. So like this we have.
Yes.
For all this type of support, we also have like types of beams.
Okay.
Simply supported beam. Fixed beams. So cantilever beams. Overhang beams like that. Okay. Do you know how this support and beams looks like? So simply support, how it will be?
No, can you draw?
Yeah, I will draw it. So simply support will be like having two support, and it's simply going to support on that. The beam going to support on that simply. So that's why we used to call simply supports and simply supported beam. So these two arrows we can call simply supports, and then the horizontal member that we can call simply supported beam. Okay. Okay, and then we can just go to fixed beams or fixed supports. Okay, it will be having like a. So like this, it will be having. Okay. So this we can call fixed support and fixed beams. Okay. Okay. And then cantilever, how it will be? So cantilever, it will be having the fixed at the one end and then free at the other end. Okay. And we can call like overhang beams. So overhang beam will be having some supports, and it will be like overhang on the both side or one side like that. See here, it is like a free support. It is not having any support. So we can call this as overhang. Okay. And in supports, we can call as something called hinge supports also. Supports, we can call something called hinge supports. We have doors now, for example, hinge supports. Okay.
And this overhang beams and continuous beams are same?
No, continuous beam is different. Overhang beam is different, because continuous beam now it will be having the supports everywhere. But overhang, it will be having overhang. For example, in building now, okay, in any structure, like for example, in flat something you can take. So we have like overhang beams to rest a balcony or utility areas. Okay, that we can say that column. So the continuous beam is something different. I will draw for you, and then I will explain. See here, I am just having one beam, right? So it will be having some columns in between. So it depends on the span of the room, right? So it will be having some overhang. So here, like we have balcony like that. So maximum, so some to 2.5 feet, 3.5 feet like that, they will be having overhang. And based on that, they need to provide the reinforcements so that it will take care of it. So the overhang beam, it will take the loads acting on the slab or on the particular beam. Yeah. Okay. So like this, like we have some basics, right? So what we can say in STAAD Pro, we are just going to analyze how the structure going to behave. This is called analysis on many external factors. We can have combination of loads. We can able to have whatever the structure, whatever the types of beams, everything you can able to have. And after inputting everything, okay. Next we can say something like analysis. So first we need to like design our structure. We can say like what to say, like how these kind of things now. So we can say first analysis and then design. Okay, analysis in the sense like what we can say, like see, we are just going to like create structure. So create structure and then apply specification, loads, everything. So specification in the sense what? The cross section, how much the cross section, and then we can go for materials, which material, concrete or reinforcement, steel, or something like that. And then we can just go for like applying the loads. Okay, combination of loads. Okay, and then we can just go for analysis. In analysis, like we do have everything. Okay, and based on the analysis, we will get some result, right? We are going to study the result. Okay, so study the analysis results, and then we can go for design. Okay, based on the study, we can say this is okay, this material, this specification is okay for the structure, this load combination, this is not enough, so you need to like redesign. So then if it is not satisfied, then we can go for redesigning it. Okay, like this we can go. Okay.
Then we can change the material and the size of members.
Yeah, we can able to change. Of course, we can change. Okay. Okay, otherwise structure will be failure, right? So we need to pass the structure. So we need to like redesign. Okay, and we have something called concrete design, steel design, like that. Okay, so these things we can go in STAAD Pro, right? And after what we can say like the codes is important. So we have some codes like so you're from India, right?
Yes, yes.
Yeah, in Indian standards, what are the codes you remember? IS codes.
IS codes. Yes, IS
Yeah.
codes.
British BIS, British standards, and we can go for American codes.
Yes, ASC.
Yeah. So like that, we must have some code practice. So we can refer the code book and we can refer those formula and we can able to like manually calculate what is what. Okay.
Okay.
So what mainly we will concentrate? Like we will concentrate on stress. What do you mean by stress? Do you remember? Like load by area.
Yeah.
Okay, that's why we are having like a kilometer per meter square. So like that. Okay, and then strain. So strain, it will be in like change in length by original length, right? Like so it will be in like a change in length divided by original length. So it will be in millimeter, like that. Okay. So these are all the, some terminologies you must remember. And what else we will go for? Bending moments. Moments. Moment. Do you remember what is the formula?
Yeah, Newton meter.
What?
Newton meter.
Okay. Okay, this is like a moment we can call like a load into distance by 2, like that we used to call, huh?
Yeah.
Okay. And we also have a shear force. So which will be in a kilonewton or a Newton, right? So we can say like bending moment is something like it is going to act on the structural element. Okay, causing the element to be bent. Okay. That's why we call that as bending moments. So when it will occur, like when you are putting some external forces only, it will occur, right? Like okay, and then we can just go for some simply supported beam, and we will see like how the shear forces and it will be. And this is like a simply supported beam with one concentrated load in the middle of the span. Okay, for this shear force, how it will be? So it will be like this. Okay, and then the bending moment, it will be how it will be. So you can call it will be maximum in the middle where the support act, where the load act on the beam, and it will be minimum at the supports. Okay, this one we can call shear force diagram, and this is like we can call bending moment diagram.
It will be reverse, I think. Bending moment diagram. At the center, it will be 0 because the distance from the load is 0.
No, it's correct. Like bending moment, it will be 0 at the support, and it will be maximum at the where the load acting. See, for example, we can call. See, this is like a W. Okay, and then how this load it will split to this supports. We can call that as reaction also. See, W it will be split up into 2. So W by 2 and then W by 2.
Okay.
So that when you add so 2W by 2, 2 to cancel W.
Okay. Okay.
Okay. So this is what it is. Here like we can say W by 2. And here we can say W minus W by 2. Okay. Okay. And here we can say 0, 0, 0. And then here we can say W into L by 2. See, we can call this as L by 2, L by 2. Nah? So half here L by 2. L by 2. L by 2. Okay. So then after the calculation, it will come W L by 4. This is for bending moment diagram. Okay.
Okay.
So how it will acting like the total distance into W into L by 2 like that, then it will come W by 4. Okay. So like this, it will vary for a uniform distributed load, how it will be. And the same, so if it is like a uniform distributed load, it will be like this. Okay, then we can say W per meter, WL per meter we can call. This is. Okay. And then here So shear force will be like, it will be like this maximum, but not linear. It will be like this actually. Okay. And then you also have a bending moment. The bending moment, it will be in a parabolic path like this. Okay. Accordingly, here also we have some formulas. So we can call here, like we will be having maximum now. That one we can call W L square by 8. And here, like we can call like a W L by 2. Okay. Okay, like this, it will be varying. So for example, if you have like uniform varying load, how it will be? So for uniform varying load, it will be like this, now uniform varying load. And then you have supports. Okay, so here it will be like different. So here also you will have some little here and then here more, and it will be like this actually. Okay, and then the moment also like here now based on this point,
Yeah,
it will be having another irregular parabolic path like that. Okay. Okay. And this is like if you have at the same time, if you have this kind of triangular load or a uniform varying load. So for this, like we can have shear force diagram, something is similar to the this one, but it should be in a S pattern. It will be half above, half below like this. And the moment also, like accordingly, you will get. Okay, so this we can call WL by 6. Okay.
Okay.
Okay, but for this kind of small supports and small load patterns itself, we are getting a struggle now. So it takes time to calculate. See here we can able to say this is like W by 2, but when it comes here, like it is very difficult to find, difficult to remember. Also. We need to memorize it, or we need to do lots of calculation to get this value, shear forces and everything. So this is what the disadvantage in manual practice. So that's why like this kind of structural analysis software programs like everywhere worldwide it is like accepted. No need to like waste our time in calculating all those. And then the STAAD result, it is like 100% equal to the manual calculation most of the cases.
Okay.
Okay, so only you need to like input all the details, and the analysis, the software will take care, and then it will give you the result. So to avoid time consumption, we are using software. So this is simple as like that. Okay.
Okay, and it is acceptable in DIVA and DM?
You mean like here, Dubai
Dubai
municipality?
Yes.
Dubai municipality, like they are mostly accepting ETABS.
ETABS?
Yeah, extended tree analysis of building system, ETABS. Okay, building system. This is mainly for the buildings, not for anything else. For if you want to like create some bridges and everything, so then you need to go with the STAAD Pro only, because for this kind of things, analysis of bridge, this kind of things, you can go for a STAAD Pro.
Okay.
In ETABS, they have that disadvantage.
I have seen that SAP 2000, there is some one software, SAP 2000.
Yeah, they have that ETABS like from CSI Inc. company. This is like a Western company, I guess. So they have separate software for bridge analysis. So they separately having bridge analysis, they separately having SAP. So they have multiple programs. So everyone, they should know everything also, so that they can go and submit in the DM.
Okay, so you know everything. You SAP 2000, ETABS, STAAD.
I know like STAAD, I know ETABS, but SAP and everything I don't know. So in structure oriented software, I know STAAD Pro and then ETABS.
You are structural engineer?
Me?
Yeah.
No, basically like okay, actually basically if I am basically civil engineering graduate.
Okay.
Okay, actually I passed out in 2013. Okay, what about you? You were mechanical, right, or civil?
Yes, I am mechanical.
Yeah, I remember you said like that.
Yeah.
Okay, actually I'm a civil engineer and I'm working in a construction company as a quantity surveyor for 2 years. You know, that quantity surveyor field.
Yes.
Yeah. So I was like working from 2000 to 2015 as a quantity surveyor, and after 2015 until now, so I was being a software trainer. So I usually teach different softwares in different companies that I work for. So totally I know 14 plus softwares. Okay. So here I'm just teaching. So 6 softwares. Okay. So what is that law? So we can say MicroStation, and then Civil 3D. You know Civil 3D. This is for a transportation and a highway designing.
No.
Yeah, and then STAAD, and then ETABS.
Okay.
and then Primavera, and then MS project. This is for planning engineers, right? Like these two only structural. So this 6 software I'm teaching here in Abu Dhabi. So we are in Abu Dhabi, and then this is like a training center teaching lots of courses. Like they also have some other trainers. They were here for a long time, and then they're teaching AutoCAD, Revit, and everything. You know, no? These softwares.
Yes.
Yeah, like that.
Okay.
Okay. So this is what. Okay. So only 2 years I was working in a field, and after that, like around 6 years, like I was being a software trainer. Okay, but here I'm teaching like this. Before I used to teach only AutoCAD, Revit, and then MS project Primavera. Before I was teaching 3ds Max like that. So this is like not like structure oriented things. In structure oriented things, we need to calculate so many things. We need to apply so many things like that. It will be. But those software, it will be very like very interesting softwares like Revit and everything. You can play with it. Like you need to build some building or houses, and then you can go for interior decorations and everything colorful. So you know what I mean, like. Okay, like that. Okay, but still, these were also very good to learn, and also it's interesting to teach like these 6 softwares also. I have taken lots of corporate batches in STAAD and also in ETAS. Also, mainly here na, in Gulf country, that too in UAE, most people coming for P6 and MSP.
What is that?
Primavera and then MS project.
Okay.
Yeah.
I know MSP.
You know that this is like similar to Excel. It looks like Excel.
Yes.
But yeah, it's very easy to learn also. But lots of tools in it.
Yes.
Okay.
So planning engineers.
Yeah. That too, now you are asking Dubai municipality, like they will accept a STAAD. But in Dubai municipality or government sectors, they are using MS project. They are not using Primavera. That's why most of the people who are working for a big company, government company, they are coming for MS project course.
Okay.
But private company, they are coming for P6 course. Like that it is.
And so, like I'm mechanical, but what are the subjects or topics I need to study before going to software?
So okay, but when which year you passed out? 2015, I guess. 2017.
18.
2018 passed out, right? Like
yes.
Mechanical. What are the things? Now, what are the software you know?
Now AutoCAD.
Okay.
MSP.
Oh, MSP.
And I have little knowledge of STAAD.
Oh, STAAD. So you are getting into civil only. After most of the people studied mechanical, electrical, and then now they're working here in very big construction Egyptian companies. Yeah.
Yeah, but I am solar engineer, so I have some knowledge of electrical, some mechanical, and civil.
Oh. And which means like MEP.
Yes. Okay. MEP. And also planning engineers work I have to do if I am a solar engineer. Because project execution and project management and project planning.
Oh, so what is the position right now?
Right now, I am a solar design engineer.
Okay. Okay, so you are in design engineer now, so you need to deal with lots of software programs.
Yeah.
Okay,
like,
so
when I receive, whenever I request from our supplier to send a strength report of the structure, they send me some send a STAAD report, or some of them send me the SAP 2000 report.
Yeah. So we have a SAP also similar to STAAD Pro, and then it is also structural program. Yeah.
Okay.
Yeah, that is from CSI, but STAAD from Bentley.
Okay. I have studied some of the references like ASCE 7 to 10.
You mean like a coach you are telling?
Yes, code.
AAC coach.
We are following American codes.
Oh, AAC coach. Okay.
Yes.
Great.
So.
Yeah. But as you are in mechanical, I can suggest you to go for a CAT. I remember like this software, the mechanical students used to SolidWorks.
No, I don't want to learn software. This STAAD I'm learning only to evaluate and analyze the structure we are using for mounting our solar panels.
Okay.
Yes.
Okay, now you are from Bahrain, right?
I'm in Bahrain, yes.
Okay. But 1 hour delay, I guess.
1 year delay?
Yeah, here 112, there it's like 212 or 12.
Yes, 1 hour. Here it is, in Bahrain it is 12 now.
Oh, 12 before, yeah, okay.
Now it is 12.
Which means like here 1 hour before you had, and here like 1 hour ahead. Okay.
Now in Dubai it must be 112.
Yeah.
Okay.
So you were okay, we are leading. Okay, no problem.
Okay.
Yeah. Okay, but for mechanical students, I'm telling CATIA, SolidWorks, and then Astron, something like that. And then that.
Okay, these are 3D softwares, I think.
These are the 3D softwares. It's good if you know, because the people also working in these fields. SolidWorks and everything. The Salt System, something that kind of company.
Okay.
Yeah. Okay, and then we will. Okay, so we will go back to the thing. Okay, I will clear all also, and we have like something called a coordinate system. So we have. So one we have like a global, and then two we have like a local. So we have global coordinate system and then local coordinate system. Okay, so in global coordinate system, how it will be like I will draw here. Like we have x, y, z, right? X, y, and z. Okay, so x and z only we need to consider as a floor plane. Okay, not z here. Y only in height. So instead it will be like this only. And like this is for common for all the elements. Okay, it is not going to change. But local coordinate system or cylindrical coordinate system like that we do have also. Like it vary for each and every plate. For example, if you have some cube, na. So it vary for all the things. See, here it will be different. Here it will be different. Here it will be different. So like that, it depends on each and every element. That is called local coordinate. So it's keep on changing according to the elements. Okay, but global, it never changes. So accordingly, you need to input the loads. Okay.
Okay. Global means what? It can never be changed. Means there is a point whose coordinates are.
No, in global we have like x comma y comma z. Na. So 1 minute.
Okay. Okay. Yes. X Y Z.
So this one, this is like a common x y z. Like in graphs, what you do, like wherever if you have graph.
Yeah.
1 minute.
Understood. Same like
but local in the sense it vary. So the LX we can say LY. It is not like common. It keeps on changing according to the that member. Okay.
Okay. What is the application of local coordinate system?
For example, in structural analysis, we can able to analysis like water tanks. So in water tank, you are going to analysis plates. So for each plate, like you need to like apply the hydraulic load or something, na, according to the coordinates. You need to check and you need to apply. So for example, for this, you need to check the local coordinate, and then based on that x, y, z, you need to apply the load. Otherwise, like water will act outside, not going to act inside. So it will be like this. So the water should act like this, na, inside.
Okay.
So it depends on the local coordinate, and you need to check and you need to input the values.
Okay. Will we use this?
No, but in your case, maybe in your real life, you might not use, but we will see how to do everything in STAAD.
Okay, so we are going to use local coordinate system.
No, but very rare, but mostly we use a global coordinate system only. So to avoid confusion. Otherwise, it's very difficult. Every time you need to check the orientation. So this x, y, z for local, you can just check the orientation of the plates. So that when it comes now, you will learn, don't worry. Now the concept you understood. Global is common, local means like it keep on changing according to the elements.
Okay.
Okay. And we can say like global, it not depend on the element, but local, it completely depend on the element. So in the same x, y, z, now if you are tilting the element, so their local axis also, it will be tilted. You understood now?
Okay.
Okay, so what are the materials we will be using, or we can just go with the same thing. So materials, what are the materials? We can say concrete, no? And then steel we have, and we can go for timber like that. What else in materials we can say? Concrete, steel, timber, or we can say some composite materials.
Aluminum.
Yeah, like this, yeah. Okay, these are the materials. Okay, accordingly you need to select, and code practice also you need to follow. Okay.
But sir, in our company in solar, we are using the alloy of aluminum.
Aluminum alloy.
Yes.
Oh.
Aluminum alloy. So can we mention it in the STAAD?
No, we will see. Is there any option like a predefined option? If there is, like you can make use of it. Otherwise, like you can just check the value. Allowable permissible limits, allowable stress or permissible limits. That you can input those that value, and then it will become that kind of material. Okay, that we can do. Yeah.
Okay. Okay, next.
Then you need to know some cross-sectional details and everything. Okay. For example, like we have like a beam. So we can tell like we can start with the 9-inch cross 9-inch beams. Okay. And we can columns also, we can go for the same 9-inch cross 9-inch, or we can take a 1 feet 6 inches cross 9 inches. It depends on the requirement. Even accordingly here also we can choose the cross section. So 9-inch cross 1 feet 6 inches depth, like that. Okay.
So
And then, yeah.
In civil everyone talks in inches.
Yeah. We will be speaking in feet and inches. In STAAD Pro, you can able to use a metric or this kind of. This is like what we used to say metric, and then this we call feet and inches. Metric system, and then there's another system. Okay, we can use both. Like I will show you there. Okay, but slab we can say 5 inches or 6 inches. So, but in STAAD we can go in mm. So mm in the sense like 230 mm.
Yes.
Cross 230 mm. So 9 inches cross 9 inches.
Okay.
Okay.
Mm-hmm.
Okay, like that. Okay.
Mm-hmm.
So 1 inch equal to how much? Like we can say 1 inch equal to like 2.54 mm centimeter, 2.54 centimeter, right? Or we can say 25.4 mm.
Mm-hmm.
Okay, 1 feet equal to 12 inches. So accordingly, you can say. So 1 feet equal to 3.28 meter. We used to say, or you can convert that into 3280 mm, like that. Okay.
Yes.
Okay, all these conversions you should remember, or we can make use of the online calculators, or we have calculator in STAAD itself. That also we can use. Okay. So okay, so tomorrow when you are coming for the class now, like you bring your STAAD Pro also, it will be better. Na? So today like it's just like introduction, no problem. Otherwise you can also simultaneously practice by sharing the screen and everything. Okay. So I will start the program and then I will tell you some introductions there, some graphical user interface and everything. Okay. Now I will clear everything. So now you understood some basics now. So if you know this, like it's easy for you to like go with the software.
Okay.
Okay.
So for today it's enough. It's
enough. Like it's up to you. Like we can. Or we can start something in the software. It's up to you. You can tell me, like accordingly I will take it.
We can start from tomorrow.
Okay, we can start from tomorrow.
Okay.
Yeah. Okay.
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 Okay. Thank you. Thank you for the class.
Okay. By the way, your name?
My name is Mohit.
What is that?
Mohit. M-O-H-I-T.
Mohit. Yeah, I remember Mohit. Yeah. So you remember my name, na? So.
Yes. It's written here.
Yeah. Okay.
Hariprasad.
Yeah.
Okay, where are you from in India?
I'm from India. So which part of India do you think?
Yes, I think Andhra Pradesh.
How you know that? Like I know actually my mother tongue is Telugu only, but how you know? But I'm not from Andhra, but I know Telugu.
You don't know Telugu?
No, I know Telugu. But not from Andhra. But I'm from Tamil Nadu.
You're from Tamil Nadu, but your tongue is like Telugu. That's why I recognize it.
Oh, is it? I don't know that. Yeah, maybe Telugu people also. I don't know. Maybe actually I'm Tamil, but my mother tongue is Telugu only. Maybe that's why. You know Telugu?
Reflected in it. No, I don't know. I'm from Haryana.
Oh, okay. So you're North Indian. Okay.
Yes. Okay. Our colleagues are from Telangana and Andhra Pradesh, also from Tamil Nadu.
Oh.
In our company, we have from all over the states. All the states. Yes.
Oh, okay.
Yeah.
Okay.
Okay. Thank you, Mr. Andrew.
Thank you, Mohit. So we will meet later, and you can put your information in the group. So we will meet accordingly. Okay.
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 Okay. Thank you.